Alright, I'm doing number 62 on 6.2 for extra credit. And the question reads, the number of bacteria in a culture is increasing according to the law of exponential growth. There are 125 bacteria in the culture after 2 hours and 350 bacteria after 4 hours. So first, what you're going to do is set up the equation y equals ce to the kt, and you're gonna put 125 in for y and set it equal to ce 2k because t equals 2. So you need to find the initial value. So what you want to do is solve for c. So you divide e to the 2k on both sides, so you get c equals 125 over e to the second times k. Then you have the other equation, which is 350 equals c times e to the 4k because t equals 4 hours. And the reason why it's 125 over e to the second k is because you substitute in for c the value. So it's a basic substitution. So then what you want to do is simplify everything out. So you get 350 equals 125 e to the second k. Divide by 125 on both sides. And then you're left with e to the second times k equals 350 over 125. So then you're going to take the natural log on both sides. So the e is eliminated on the left side. So you're left with 2k equals ln of 350 over 125. Divide by 2. And you get this k value of 0.514. And then once you have that, you can solve for the initial value. So you know that c equals you have 0.514. Then you can plug it back in to this equation, c equals 125 over e to the second k. So you would have 125 over e to the second times 0.514, which equals 44.64, and that's an approximate. And since you know it's e to the 0, it's automatically 1, so it's 44.64 bacteria. And then part B asks, write an exponential growth model for the bacteria population. Let t represent time in hours. So this is pretty simple. All you have to do is write y equals 44.64 because that's what c equals, times e to the 0.514, which is what k equals, times t, which is the variable. Then on part C it asks, use the model to determine the number of bacteria after 8 hours. So then you have y equal to 44.64 e to the 0.514 times 8 because t equals 8. You plug it in the calculator and get 2,726.11 bacteria. Oh, sorry, that should be rounded. Sorry. So it should be 2,727 because you can't have part of bacteria. And part D is, after how many hours will the bacteria count be 25,000? So then, yeah, it's 25,000. So then you put 25,000 in for y. So here's 25,000 equals 44.64 e to the 0.1 0.514 times t. Divide 44.64 on both sides. Multiply both sides by ln. Then you divide by 0.514 and you get t equal to 12.31 hours. And that's it.